Yes, so my name is Zev. I work for Ignite. This is kind of like a talk that's based on a blog post I did a couple of years ago, and actually I keep seeing the same pattern over and over, so I thought it would be worth like spending some time on this. To tell the story properly, I have to go back a couple of years to 2012, February 5th, 2012. Unfortunately, actually 2 a.m. What happened? I got a phone call. I was in bed. This is not me, this is for dramatic effect, right? All systems are down. Okay, so what now? I get up and an evening or night of like dramatic hacking starts, right? Hollywood style hacking, fixing all the systems. So a little bit of context, right? 2012, where was I? So I worked at the time for a company called Cloud9 IDE. Has anybody heard of this company? I see a couple of fingers, very good. So basically what this company did, or still does actually, is build an online IDE. So rather than downloading Eclipse or IntelliJ, you just go to your browser, c9.io, and you log in and you have all your files there, you compile, blah, blah, blah. And it's kind of important that the system is up, right? Because, you know, like if the web page doesn't load, your files don't save, that's kind of problematic. And this whole system was built on Node.js, except this was 2012, and Node.js didn't look like this. It actually looked a little bit like that. Actually, it looked even different than this, but I couldn't find a logo. It's like gone on the internet, I think. So this is Node in 2012. So anybody in this room used Node.js in production in 2012? Yes. Oh, I feel bad for you. I hope you had a different experience than we did. We were using Node 0.4. We're currently at 6.0. Of course, version numbers don't mean anything, but 0.4 actually is a pretty good version number, I should say. So what was the problem that night? We were using this Node module called cluster. And generally what cluster is for is it allows you to kind of like load balance across multiple processes. So Node.js, as you probably know, is based on JavaScript. JavaScript typically runs in an event loop. It's single-threaded, right? Modern computers, I would say, like even your mobile phone has multiple cores. So how do you use all those cores? Well, you split the work across threads, and Node doesn't have threads, so you split it across processes. So cluster allows you to do that. So it basically sets up this system where one process handles all the incoming requests, and then it spreads it out to all the different worker processes. And the idea is that it spreads this evenly so that each like processor is doing the same amount of work. Except this didn't turn out to be the case for us. When we were looking at like what was going on, we saw that one of the workers was using like basically everything, and the other processes were basically not doing anything. And as a result, like requests would never end and were rejected and this kind of stuff. So how is that possible? So we looked into this. Luckily, at the time, we employed half of the Node core team. This was basically the way to support that. The core team was quite small at the time, 4 people. Later, we employed 3 out of 4. So they got to work. And as it turned out, the issue was very specific to the environment we ran it in. So you probably all know Joyent as the company behind Node to some extent. They are, I mean, now they are owned by Samsung. But their main business is they have a cloud business, right? And they run SmartOS primarily. And SmartOS is actually not new technology at all. It's based on Solaris, which is like super, super old and stable. And we use them because of it seemed like really cool technology. But as it turns out, the combination in SmartOS was not as mature as you would like. So what we actually had to do, we had those guys they fixed these issues specifically for SmartOS. We prepared a new Node.js 4 build, and that's what we deployed, right? And then all was good. Everything worked. All right, so you may think, okay, that's a cool story. How does it apply to me? So basically, this is a story about startups, right? I work for a number of startups, and anybody here, like who here works for a startup or has plans to work for a startup or ambitions? Yes, okay, so this is for you. So here's what I learned, like why do you need startups at all, right? So this is my view, maybe not be the official like definition or reason or whatever. You start with a good idea, okay? You have a good idea. then the first challenge is to find product market fit, right? You have to show that your idea is actually not like a cool, oh, that's a cool idea, but actually people would use it, right? You have to build something where people buy it or start to use it, and you actually gain traction with that. And this is really hard. Then the other advantage of a startup is that you have a small group and you can move fast, right? Like big companies like Microsoft can build products, but it takes a long time. Startups can do things much faster. And then of course, like if you're anything like me, like this is an opportunity to try out like bleeding edge stuff, right? I'm going to start a startup and I'm going to use Elixir, React, Cycle.js, Go, AWS Lambda, Rust. Like this is, back in 2012, this was Node, right? But actually, like if you take only one thing away from this talk today, is that actually no. Those first two things are really, 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 really hard. 90% of, like, I don't know, like random statistic of startups fail because they cannot find this product market fit, right? Or they slow down, or they're not fast enough. You don't need any distractions. Like, if you want to succeed with your startup, you have to pick your battles. And using new technology may not be the right battle. So, going back to my Cloud9 example, this is what our stack looked like. So actually the history of this company is that it used to be called ajax.org, and this was like, I don't know even when this company started, let's say 2009, 2010, there was nothing stable in the front end, so they built their own like ajax.org platform, like UI framework. Then they figured out that actually there's not a lot of market for framework, that people don't buy that kind of thing. So they said, okay, let's build products with it, and Cloud9 was one of those products. So front end was all built using this custom I mean, nobody outside the company was basically using it, so kind of custom framework. And on the back end, we used Node.js, and like all over the place, right? We just used Node.js. We ran on SmartOS in the beginning, later we moved to AWS. And as like a primary data store, we used Redis because it was cool and fast and stuff. So only Redis. So here are some of the things that we ran into back in 2012, right? So now we have like 200,000 lines of JavaScript code. So how do we organize that? There wasn't, I mean, on the front end, there wasn't really it wasn't really like a module system yet. On the back end, all this stuff, like in Java and other frameworks, like framework platforms, all of this has been figured out. We had to play with things like dependency injection, modularization. Should you put all this stuff in one repo, multiple repo, package management, all that kind of stuff. And it took a lot of time, right? We figured it out. You figured this stuff out, but it takes time. Another thing, I mentioned we were on Node.js 0.4. If you are very like a Node.js historian, you would say, well, in 2012 we had 0.6. Why weren't you on 0.6? Well, APIs changed quite, well, not dramatically maybe, but significant enough that it would take a lot of time to migrate from 0.4 to 0.6. So for a long time, we're stuck on 0.4. And this is kind of problematic, and again, takes a lot of time and energy, right? How do you do releases with going down? Node servers that you have to kill and like restart to go back up. You don't want this to cause any downtime. We were using WebSockets, so there were like ongoing connections. You cannot just randomly kill node processes. So how do you like slowly like rolling out your releases? It's all solvable, but it takes a lot of time. Exceptions crashing the Node.js server, right? So if you have an exception that you don't catch, like the whole process blows up. Nice Node.js feature. I mean now, like, I think later in 0.8 they introduced some things that kind of mitigate this, but it's still to some extent a problem. So we had a lot of like random crashes. Another one, freeze up. So this is actually common to Node.js and Redis because both are based on like a single event loop. And that means that if you do anything CPU intensive or anything that takes longer than like a couple milliseconds, the world stops, right? If you are going to parse like a 20 megabyte JSON file in Node, and it takes a significant amount of time, like nothing else happens. All the other requests are not doing anything, right? So we from time to time saw that like the response times like, jumped to sometimes seconds, and we would have to figure out what the hell was going on. In Redis, similarly, like if you do like a keys query or something on like a ginormous database, and we sometimes like accidentally did that, your whole database is frozen, right? It doesn't do anything else. All stuff that you will find out, and we did find out, but it takes a lot of time and effort. So I would summarize this time as like party, party, party. So all of this is distractions, right? Startups are not primarily about this. Like the first two are hard enough. You don't need the third. You have to pick your battles. So who knows this expression? It's known. Like, okay, just like, this is Murphy's Law, right? I actually just before the session tried to Wikipedia like who this was and when he lived. But Murphy never operated at scale. He was an optimist, I would say. This is my version of Murphy's Law. Anything that can go wrong will immediately blow up in your face. It's Friday afternoon, 5 p.m. We have a small release. Nothing can go wrong, right? Well, that seems like an edge case. I don't think any of our users will ever hit that. Boom, right? So whenever stuff blows up, you apply this technique, well, we at least apply this technique called 5 whys. Are people familiar with the 5 whys? I see some hands. So this is one of many good things coming out of Toyota, the car company, in addition to Kanban and some other things. And okay, so let me just show you roughly how this works. I mean, you can probably guess it by the name, but so some event happened, right? Our server crashed. So what do you think happens now? Why, exactly? Why did it crash? Well, we didn't handle all the error cases. Why didn't we not handle all the error cases? Well, we only have happy path tests. Why do you only have happy path tests? Well, we don't have any time to write more tests. Why don't we have more time to write tests? Anyway, no more space on this slide. But you know, like, I don't want to tease the answer. But this is the point, right? The idea is that you keep asking why, eventually get to the root cause, right? This is for root cause analysis. So I developed a kind of like quasi-related technique, which I call the 5 reallys. Allow me to demonstrate. We should use Node.js because it's cool, fast, and scalable. Really? Yes. Really? Yes. Really? Really? Well, yeah, I think so. Really? Okay, well, okay. Speed is not that important, but scale is. Really? Well, no. Realistically, we only expect about 200 users. So, I mean, okay. So, what's the secret here? How do you apply this technique? The secret is you ask really until the person realizes that he or she is wrong. I mean, I joke about this, but it's funny how many technology decisions are based on like, hey, I read this on Hacker News. Like, no offense to all the people in this conference. There's a lot of bleeding edge stuff here, and you should definitely play with it, but it's like, if you base your whole, like the future of your company on like, hey, look what I read on Hacker News this morning, let's use that. Apply this technique, right? Okay, so this is what you've been waiting for. This is my attempt at like this is a visionary picture. Like Google Photos, Zeph visionary. This is what I found. Go and build amazing startups, amazing products. Build them using the most boring technology you can find. You know, the stuff that's years and years old, like Java, like PHP, yay, like Python, like even .NET. You have no idea how great it is that you can Google any random problem and like find results on Google. don't underestimate the value of mature technology. Pick your battles. So you may ask, really? Are you really telling us that we shouldn't use anything new? Like, how do we move this world forward if we just stick to Java and PHP forever? Well, okay, so there is one caveat here, right? So as I said, the purpose of startup, find product market fit, move fast. If you can find bleeding edge technology that supports those two things, that makes a lot of sense, right? But think about it. Apply the 5 reallys. Don't optimize prematurely. So here's some, I like this slide. So this is a couple of things. So there's DynamoDB, which is basically, if you're not familiar with it, like AWS, like infinitely scalable data store. I mean, it scales with your wallet, I like to say. And there's CoreOS, which allows you to deploy basically Google scale like data centers, right? And microservices, which allows you to scale to, I don't know, big infrastructure, but large amounts of teams. So what do all of these have in common? Sorry? Interesting. Actually, you can start small, he said. So actually, okay, so my commonality that I was looking for is that you probably don't need any of these. Because you will never, like 9 times out of 10, 99 times out of 100 maybe, will hit this scale, right? You cannot possibly predict the future, so don't even try. And even if you, I mean, there are, of course, exceptions to this. There's always exceptions. So if you are going to do like big data analysis, you're not going to store this stuff in a SQLite database, right? And there are cases where some of these things make sense in a very specific, narrow area. So a couple of months ago, I was talking to a CTO of some weather company in Austria, and they said, well, yes, we have a microservice. So this is a weather company. Can you guess what this they had one microservice. Can you guess what this microservice does? Send emails. No. I think it did time zone conversions. So I think the story, if I remember correctly, the story was that they used different technologies, C++, Java, like all over the place, and all of them did this slightly differently. So they said, okay, enough. We're going to build a microservice that just does that, and everybody calls this microservice, and that's how we're going to use it. This is a good idea, right? You just apply one of those things in a very narrow area. You don't go full in. You don't say, I like Node, let's build everything with Node. I like Redis, let's store all our data there. You just say, yes, this is a very specific usage. This seems to make a lot of sense. All right. I gave this talk earlier and somebody said like, hey, you misspelled TLDR. Too long, didn't listen, is what this stands for. Don't take your tech choices too lightly. I said this before. Don't run after the latest, hottest thing just because it's hot and like that's what you like to do. Pick your battles. And that's it.
Very nice talk, Seth. Guys, any questions?
Interesting talk. I just wonder whether developers are the right audience for that. Because for developers, telling them that the boring choice is the right choice is maybe not so motivating. So how do you motivate people if you ask them to use the most boring technology that they can find?
So I hope, and actually that's very relevant. Like we kind of face similar issues at Ignite where there's a lot of Java. I hope that people don't only care about writing lines of code, but also about what it does and if people actually use it. Personally, the only reason I write code is that somebody will find it useful. If I have to spend 10 times as much time on writing code and then nobody uses it, or like even write only a couple of lines but people don't use it, or it's completely wasteful, or I have to rewrite it all because like we have to upgrade to some version, I prefer to like write something that people actually use. Basically, what I'm saying is like I hope that even developers, which I count myself among, of course, care about what they build, and also, even if they have to use, like honestly, at this point, like I did all kinds of different languages. I started with Haskell and Perl and all this kind of stuff. Like at this point in my career, like honestly, I don't care. I just want to build stuff that works. I just want to build stuff that is used. I don't care if I have to write Java or PHP or Java. I mean, my particular team uses JavaScript and Node, ironically, but in 2016, so that's okay. But yes, but I think it's important to understand also for developers that there's a bigger context than just like this specific programming task, and that's the world we live in, right? And I think it's a healthy counterweight to all the like, ooh, look what I built, you know? Yeah, sorry, but I mean, there's great stuff here, and everybody should play with it, but like, think about actually using it in production. Yes?
So microservices are often seen as a way to scale like human problem, basically too many people and way of parallelizing teams. What's in your experience is the size of a developer team when it's starting to make sense to actually go with microservices, where it's not working anymore, just having everybody working on the same thing? If you have any hints on this one.
Team size. I mean, basically, I mean, what you say is absolutely correct, and I don't think many people actually realize that this is what the problem that microservices solve. Like many people think that microservices is all about like modularization, but I think indeed, like you say, it's a way to scale up with teams, right? You have 10 teams that now want to release stuff, and now everything is put into a giant monolith, and this is released at the same time. It blows up, and then people have to figure out who's responsible for that, like which change caused that. And if you have microservices, this is like, at least theoretically, you can like release, every team can release their own little service independently of the rest. But that's not answering your question. This is repeating what you say, rephrasing what you say. At what scale does it make sense? I don't know. Like currently, Ignite has about like 100 something developers. We still operate in a monolith level, let's say, but I think there's talk of like splitting off some bits and pieces. So honestly, I don't know if I'm the one to answer that. Like you need somebody who did bigger scale stuff. Wow, that's a really long answer with like a really long non-answer.
So, any tips on judging technology? Is it enough? Is it mature enough to jump on it?
Well, I mean, the obvious thing to look at is like who else is using it. So there's a couple of risks with like, adopting new technology. One is that, and we actually found this also, that people may just abandon it. Like somebody's really enthusiastic, works on it on a couple of months, couple of years, and then like disappears. Then you have to be willing to completely like adopt it, right? You have to take care of it. We found this with Node also, that there were lots of libraries that we used that were no longer maintained. So we just, whenever we added a dependency, we had to assume that at some point we just have to like maintain it. So if there's a bigger company backing it, if there are big companies that have an interest in it, like if you know that big companies that are going to stick around for a while have like production stuff running there, then you should probably be somewhat safe. But like even, I mean, I would say that you can even play with new stuff that's much more immature if you just like give it a very narrow focus, right? Like if you say, well, we have to do a lot of, I mean, okay, Node is already irrelevant. I mean, it's like old, quote unquote. But even if you would say, okay, we need to do real time, and we are only going to use Node or something like that for real time, and the rest we still use the stable stuff. And then, like, in case it breaks, you know, like, okay, real-time features are broken, but we can handle that. Like, if you start out small and scale it up over time, that's like a safer approach in general. And then I would say you can get away with pretty new stuff as long as you don't go like all in at once.
Hi, very good presentation. I would like to just point out that there's also the other side of the coin regarding new technologies, because we are a fairly small company, and when people were talking about Elixir, which was becoming a thing, and everybody said that you cannot be hired, you cannot make Elixir for a living. We were hiring for people who will create the software in Elixir. So for fairly small company, it was possible to hire really good developers just because they wanted to make code in Elixir. So what's your take on that? Thanks.
I see. I mean, that's a completely separate issue, though, right? Like, well, okay, so you can be lucky because it's definitely a way to attract people. You say good people, like I believe you, but like of course, like the amount of years of experience is going to be very short because Elixir is pretty young, right? Elixir is in specific is kind of specific because it's based on Erlang, which is like massively mature. So I mean, yes, you can probably hire easier. The question is like, can you hire people with experience? Probably not, because nobody has experience. Okay. Right. But like we did the same thing, and actually the message is kind of like, if you adopt this, you have to hire core committers. Yeah.
Hey, great talk. There was a question about that it is not for developers. I think it's for developers too, because all of us are doing startups, or many of us are doing startups after hours, and really, these are startups. It can be a good product. Where can you define the point where we are doing the code fast and it's ugly, and we are doing code good in the startup and it's taking a long time? As we are working for the small company, we can do bad code. It's fast. It's one-time product. When we are working for a big company, we are doing a very good code. It's also bad because it takes a long of time. In the startups, there somewhere have to be defined the point between the bad code, fast code, between the good code test, etc., etc.
But okay, so to be clear, this is not technology like platform specific. This is just like good coding practices. Like, do you go fast and ugly or slow and?
It's about the startups that you have told about picking the battles. Where is the point about making it fast and making it good?
Right. Yeah. So this is a tricky balance in general, right? Like, because you, as you say, like if you are going too high quality and too slow, you may as well not do anything. So what I see a lot, and I'm sure what happens a lot, is like there's a lot of hacking in the beginning. Everything goes really fast, and then all of a sudden stuff starts to break, and then you have to like slowly like clean up, right? And sometimes this is where stuff goes wrong. So I kind of like realistically, you have to go fast and maybe a little bit ugly, but not too ugly, to be very specific. And then like clean up after yourself slowly, bit by bit afterwards, right? So if you are going to, okay, so this is a whole different, completely separate discussion about like, hey, are we going to apply test-driven development and this kind of stuff, or are we just going to hack and reload the page and see if everything works and yes, move on to the new feature? I don't know if there's a one single answer here. Like, I don't know what to say about this. It's there's not a single answer. Like, if you are going super clean and super high quality, you may just be too slow to get the stuff done that you need to get done in time, right? So you probably have to cut corners. Like everybody's cutting corners in the beginning, and then eventually you grow to a size where you stop doing that and you start to slow down and you become one of the established companies, basically, and then the other startups are going to push you out of the market again, right? This is the cycle of life, I guess.